start. So, the name of the talk sounds as if it's like for data scientists, or probably data analytics, or at least for product managers that want to do some data analysis, right? Well, first of all, like everyone eventually or accidentally can become a product manager, right? Yeah, these guys know. And but today I will actually like make a talk specifically for like general Kotlin developers. So mostly for you. And my name is Roman Belov. I'm in charge of Kotlin Moonshots group at JetBrains. We are focusing on finding new applications, new directions, new innovative approaches for the Kotlin programming language. And today I'm going to show some of our products. And let's start. So let's, for now, drop this data frame thing. And like think about Kotlin and data. What comes into your mind when you think about Kotlin and data? Data classes, right? Exactly. So data classes was a real innovation. So I mean, like 10 years ago, when we were visiting like conferences, the most impressive way to convince someone to use Kotlin was like to show something like this. So here's a data class, and here's the same in Java. Actually, yes, this. Oh, yeah, this. And all Java developers were like, what? Sold. 5 years later, they coincidentally got records. And Java developers like think that they like kind of data classes. But nowadays, it doesn't look so impressive now for them. So today, my task is to show you something similarly expressive like this, but for you. So there is a good tradition to like showcase everything on Kotlin Conf using example of Kotlin Conf app. And let's say I'm a backend developer, actually, or multi-platform developer. So, and I want to write a Kotlin Conf app. It all starts with session-ize. Who submitted talks to Kotlin Conf? Okay, then you know what is session-ize, right? So you used it because you have to submit it using session-ize. And all the data about the talks, selected talks, and so on, is actually stored on their side. Of course, they have REST API that can give you some like actual information about the talks. And then you can like download this API and use it on our Kotlin Conf app backend, transform this JSON file, and then you can provide some other REST APIs, but for client stuff. So it's like kind of a traditional backend for front end, or you can call it API gateway or something. Question: who ever had like similar tasks? Quite a number. I mean, like almost everyone, at least partially. And today I'll try to show like how to improve it, how it can be done probably easier than you used to. So first, let's start with this REST API. What is the best way, what is the easiest way to go to REST API in Kotlin? Cater, right? Cater client, obviously, right? So, but not just Cater client, but also Cater client with Kotlin notebooks. Let me first show you, and then I'll explain everything. So, like, it's a new project in IntelliJ IDEA. I'm creating a new Scratch file with Kotlin notebook inside. Then I say, like, okay, let's use Cater client. Now it's downloading it from Maven Central. And now I have, like, HTTP object that I can get and session. Okay, it was probably inside session. Sorry. Yeah, I have it. Cool. I have OK. It doesn't look good. I need to see what's inside. And it's some JSON, indeed. So I can easily navigate through it. But like it's not what I need. I actually need something which I can play with. So I will deserialize this JSON. And now I have a response which actually has all the fields, like with, for example, sessions. It's actually essentially a collection of data classes. So I'll take then, I don't know, like filter, it description contains multi-platform. Oh, I can't do it because description is, sometimes we have no description. So we need to somehow omit it. Oh, cool. And now let's take, for example, the titles. Great. So, quite easy, right? Actually, it's, well, I'm forbidden to joke about JavaScript, but it looks like we made a JavaScript from Kotlin, right? So the idea is, like now, let me explain what happened here. So let's start from the very beginning. First of all, what is Kotlin Notebooks plugin? Who ever heard about it or used it? Also quite a number of people. Great. So I will briefly explain that it's a plugin. It's available for IntelliJ IDEA Ultimate. So you just install it and you are done. So you don't need anything. So Notebook itself is a file. It has extension IPython notebook for historical reasons, because like it's a kind of a standard, and if you open this file on GitHub, for example, it will be nicely rendered. So, but we use this protocol, this format, but it's all Kotlin inside, even like, of course, the Jupyter itself is also rewritten in Kotlin, so there's no Python on this machine at all. Okay, there is Python, but like I don't use it. So, and also, yeah, it can be created in Scratch file. So usually I use them as a Scratch files, as you can see, because like sometimes it's just like fast. I don't want to put this file somewhere in my project, but of course if you need to share it with your colleagues, you can do it. So the first line, use Cater client. Actually, this like line makes almost all the magic. So first of all, it downloads dependencies. Every time, like we are in 2024, and every time in 2024, when I like copy and paste Maven coordinates, I feel awkward. So instead of it, for like most commonly used libraries in Kotlin notebooks, you actually have like auto-completion. They are always on the latest version. You can specify the version if you like, but like you can, for example, okay, take like dataframe and also like download it, and it will automatically resolved. Next thing is, and for this I'll do one, okay, I'll create a new notebook and do a small trick here. There's a like, how it's called? I've forgotten the small trick. It's track. Oh, I got what's happened. Okay, it was a small bug. Track execution. Okay, good. So now I will do the same. Use Cater client, but I will see all the code which is executed behind the scenes in the same context. So it's actually first downloading repositories. Next, it's specify some default imports. So you don't need to like import everything, because you actually import the same stuff every time usually. Next, you can specify results visualization. So when we had something like this, it was like body as text, yeah. There was like some code which actually checked if this string is JSON. If it's a JSON, then it draws like in a pretty way, so you can like collapse some parts of it, interact and so on. But if it's a simple string, then it's going to be just a simple string. For example, like this. Good. And next thing, which is also really handy, there are some callbacks. First one is like when the library is loaded, you can also execute some code. In that case, we actually create a HTTP variable that is like default Ktor client for us. And the last but not least, and probably the most important part, you have a callback on creation of any variable in this context, which works like this. So when I run, for example, this thing, this deserialized JSON returns very specific type, like which is called deserialize this, and it substitute this variable on the fly. So when I like execute it, it's actually did the like quite pretty thing. Oh, quite a lot of code. I mean, like, but it's mostly because it's a content of JSON. So it's actually like generate the data classes based on the JSON, automatically adds them to our execution, and oops, something was, yep, copy. So now I can, for example, put it in my like file. Okay, there's something like a data type. It was some type alias. Typed any is any nullable any. Good. So now I have all the. Nope. What's wrong with you, dude? Sorry? Double nullability. Yeah, I forgot an alias. Oh no. Sorry? Oh yeah. It's double nullability. Yeah, gosh, sorry. Nope. I should remove this one. Yeah. Okay, good. Got it. Good. So, and the idea is that then we use Ktor client to deserialize these, like the result to this data class. Very simple, no magic at all inside, and yeah, we did it. So the first part is done. We actually got some collection of data classes. Okay, let's go. First, yeah, also like there are some other like tons of other execution. What is really good, it's thoroughly documented. So if you want to have something similar for your library, you can easily do it on your side. So this thing is actually defined on the library side. So you can like add one kind of like integration class, define some methods in it to specify the behavior of the library inside the Kotlin Notebook and get all this magic done. And the other thing is actually if you contribute it into the list of the supported libraries, like we have some like automatic stuff to have it always up to date. So you will release new versions and new versions will automatically go to Kotlin Notebook. So, and it was part one. Let's listen to Mozart. Data classes. So we have a collection of data classes, and question is actually What's wrong with data classes? And the problem like appears quite soon. So let's say we have this data class and want to add a single field to it, like for example date. The question like basically why we want to add it, because for example if I like add it and then I want to use it like in like other functions, and so if for example it's a split of my pipeline, data pipeline, then I have to store it some way, right? Somewhere. So let's see how to do it, because you all did it. Let's just discuss who and how. The first option, who did it like this? Yeah, usually like the problem is in this part. So you have to copy and paste quite a lot. Okay, the next option could be definitely this. Who like usually do it like this? Actually, I do it usually like this. And yeah, so, but this time the like problem is that we have like kind of a second-class citizen in my data class. Yeah, so I have nesting now, which is like kind of awkward. I mean, like, especially because you have this nesting not because of the like the internal structure usually, but mostly because of the way how and when you add or delete properties. It would be cool if I can do something like this, but I can't do it because data classes are final, and like there's no way to actually inherit from them. The most awkward way, but very like usual, is like this, and it usually leads to this famous code. So you transform it, and like then, like in the end, you have lots of like these unnamed classes, and of course you can actually pass like instead of it some names, but then like you find yourself like duplicating these names in every single like in every next routine. So it seems like there's like currently no good way to do it. Oh yeah, one more important thing is actually to use extension property, which is a nice way, right? But the problem is that it's just a like pure function. Yeah, so it has like when you execute, for example, like get hash code or something on this class, this function will like not taken into account. So and also if it's something long, then you have to implement some caching strategy and so on and so on. So it's like also not an option. And it's all good if you want to add something. But if you want to delete, for example, one property to hide it, then like no way. You have to copy and paste all the stuff. So, and yeah, there is actually like, and it's not something that is like rare, because every time you split it, or every time you want to provide it as a REST API and put it like and serialize it to JSON, you have to define a class, right? So, what is, dataframes. Now we are like slowly go to dataframes. Dataframe is such an abstraction that actually can work with data way more natively. I mean, like not natively, but like in a handy way. So first of all, what is data frame? Actually, it's a table. Every table has its own type and its own name. And like if you use Excel, you all know what data frame is. So then you can like change the order. Actually, order doesn't matter a lot, but like sometimes it matters. You can delete some columns. You can add columns. You can actually, for example, I don't know, take some column based on the values, group its values, and for example, like using like another column, you can pivot it, and then this like values becomes new names of columns and so on. So it's pretty versatile architecture, but the problem is how to explain it like in Kotlin, because Kotlin is a statically typed language. And it's like why we love it. But the problem is that it's also why we hate it. And so let's take a look. Today I hope to have quite a lot of light coding. So let's take, for example, these sessions from response and just convert it to data frame. So now we have data frame sessions, and it looks exactly like on the slide. So we have some columns. We can reorder columns. We can sort them and so on. So let's, for example, do the same stuff that we had here. Let's filter columns that have some description inside. So, and actually it works. I mean, okay, instead of doing this, I will do it like this. So now we have 10 sessions that have, I didn't even change anything. How does it work? So the problem is this description thing looks like a property, right? And actually the idea is that when I created this session, I automatically analyzed the structure of this data frame and created extension functions describing the columns. So, not functions, but properties. So column is actually name and type. It's exactly property. So yeah, so for example, I can address, let's say, title, it's going to be a column. So I can, for example, take first element, it's obviously registration, and I can do it, for example, vice versa. I can take 0 element, it's a row. I can take title, and it's also registration. And if you know Kotlin standard library, then it will be really easy to you to work with this structure. Let's do something. Let's try, for instance, add this date to read. So I will add date, and for example, take it from, we have this starts at, and if we check the schema, session schema, then this starts as is currently a string. So I will take starts at and say to local datetime and take the date. Nice. Now I have one more column in the end, which essentially has data. So I call it df, and now this df thing actually has data. And this date is actually was automatically generated at the moment when I created df. So let's try to use it, just to let's say we want to create a scheduler and for today. So what we're going to do, so we take our sessions, we will convert, for example, starts at and ends at with it to local datetime. Cool, now they actually local datetimes here. Also, I see that there are lots of stuff which is service session. It's not interesting to me, so I filter them out. Filter is service session false. Good. And for instance, I also have rooms here, but rooms is actually room ID, so I want to have rooms as well. So let's create rooms with response rooms to data frame, and I will convert room ID with, so in data frame rooms now, I need to find a first, what rooms have, I don't know, like ID probably, yes. So ID is equals to, let me think, so room ID, and for instance, I will take name for it. And let's do it. And where is my room ID? Yeah, here it is. So now it's like actual room name, so but it's better to rename it. So I will rename room ID to, let's say, room. And let's call it somehow. So for instance, converted. Cool. Now I have a converted something is broken. Rename, oh, because it's not two but into. Yep. Next thing that I want to do is, for example, take this converted thing and filter it based on, like, I want to like get the today's scheduler. So I will take starts as day of month, and today is 23. And cool, now I have all today's sessions. Let's, for example, select, oh, and like we can actually just pivot it now. Pivoting based on room. Oh, we actually probably need to sort them. So, for example, sort by start time, start at, and group by also start at. Let's take a look first what happened if I group them. So now I have all start times, and actually inside like every group I can actually like go deeper. Oh, it's not a good group, I would say. Like, for example, here I have like 6 rows, so it's a group of 6 rows of talks which started like in the same time. And like for now, for example, I can pivot them based on room, and yeah, take, for example, values of, I don't know, like what we have, name, how it's called, title, right? Cool. Now I have a like data frame, which is like, let's open it. Has time in the first column. We also have a column room, but we actually can easily like say that I don't want to have it just like this. And also I have lots of nulls because like default value for string is null, so I will substitute it with empty string. Great. So now I have a scheduler for today, and what is really cool, it's already updated. Because like of this our file error. So it looks a bit like hard to understand probably, but if at the end we look at the actual code, it's pretty simple. I mean, like it's easy to read, and but there is like, you can probably like trick me, right? And say, hey, but you can't, for example, use room in this cell because like at the moment there's no room column. Or for example, before, like in this cell, I've converted start as to local date time, but it actually doesn't know like because we generate new properties at the moment when we start the cell. So we can't use this start at that moment, which is like the kind of a problem, and I have to always like create new variables, for example, like this, and based on it, like split the execution so I can generate the properties I need. It's still pretty like handy because like you have auto completion for all the stuff and so on, but sometimes you have to use to it. I have like one more example for this. Probably it was like HTML table. So for example, if we take this today thing, we can actually generate a simple HTML based on this table, and I don't know, like let's put it in a gist, and it's gonna open, hopefully, because yesterday it was broken on GitHub, now it works. So like descriptions, it's our huge string in the beginning. Yeah, so and in the end we have like a nice HTML table, for example, because Notebook supports HTML out of the box. So that's basically what dataframe is. So now we have like some taste of it. Our dataframes are a bit more tricky. So they are not just plain structure, but you can also group several columns together, and also you can take any column and any cell and put a data frame, small data frame inside this cell. It sounds crazy, but actually if you think about data classes, you understand why we have it. Because data classes can contain data classes inside them. So if you want like a hierarchical structure to convert to data frame, you have to design data frame hierarchical also from the day one. That's how it works. And like let's take, for example, we have this here, I think, categories in response categories to data frame. So these categories actually has some nested classes inside. So I can, for example, say like let's go deeper and like scan several levels of classes. So now, for example, inside items, I can navigate inside this group and see what's inside. And it's like a small data frame because it was actually the array inside the original like value entry. So, and for nested groups, it's also quite obvious. Yeah? So if you have, for example, data frame of some stuff that also have some classes, not array, some properties, not arrays, then it's actually the same like grouping the columns together. So what does it mean? It basically means that we can take any JSON and convert it to data frame. And like, let's have one more example for this, and it's gonna be like, let's create it from scratch. Or probably, yeah, okay, I think we have enough time for it. So I will this time use data frame, and also we'll, yeah, let's download it. For some reason it doesn't cache. So let's read JSON from, oops, not from empty string, but from GitHub endpoint. So actually I'm trying to get commits from Kotlin from GitHub. So I took 30 commits because it's a limitation of the like API. And I have like this perfect structure which is like looks very, very nested. And I can use the structure, so like let's find the result. And yeah, probably that's it. So I can like download all the commits, and for example, like let me show you draw this wonderful chart like on GitHub. For example, I like download the commits, analyze them, draw the chart of the number of commits per week, and also the average length of commit message per week. And we see that, for example, engineering excellence at Kotlin repository is growing steadily up, or probably it's because of the ChatGPT thing. So it works like pretty easy. Like, I mean, the code is very easy to read. So that's basically the idea behind the data frames. So the last thing today, yeah, it's also about Candy. Like, it was drawn with Candy, which is our data visualization library. And there's tons of different stuff that you can draw with this, so there are lots of examples. So just like go to the website and click on any of them, and there will be a code how to draw them. And now we are going to the most interesting part: how to use it in production. So it's cool that we have a notebook, and it generates it for you and so on, but it's like very, like, you can experiment, you can do some exploratory analysis, but how to use it in production? And let me show you. So the idea is very simple. I will like take my code that we wrote together. It was probably this thing, yeah, okay. And I will take, okay, I will write it probably. Let me find it. So it was this part. I copied in like the IDE. It's actually the latest EAP version we have for IntelliJ. And I will create a data frame, which is data frame read. Yeah, we will have just a little bit less for questions. So we have still 8. So, and yeah, and actually it was a JSON, right? So I created a data frame, and now like I want to get some properties, right? This generated stuff. But like for this, I can just import the schema. And now this data frame, actually this like have all the stuff. It's like automatically, yes, right, like on resolve, it goes to the endpoint and get the, like analyze the schema of the data frame. And of course, it's like cache it in a like nice way, so you don't like actually need to go it on every resolve or something. So let's, for example, like so now have sessions, which is probably sessions 0, right? Because it was like top level object. Also, I can put like rooms, and it looks like this, right? And I will go to my code and just copy and paste it. So it was this, right? So, and also, I will copy and paste this part as well. Oops, sorry. And the cool story about it, that it all works. So I mean, like literally works. We evolve the schema on the fly with a data frame compiler plugin. So when we like converted starteds to local datetime, now, for example, like I can use this for starts at day of month or something. So as a because it's resolved and it understands what's going, like the new schema. And it looks like magic. So for example, here we introduce room, which is a new column name. And here we use it as a property, and it's available in auto-completion and like all this way. So essentially, to create this new JSON, the only thing which I really needed, like to write this. And yeah, and for example, like let's verify that it actually works. So I will also just like print it. And hopefully, yeah, it's so long to compile it, Gradle thing, but if I can't grab it, it's weird. So I can scroll it, yeah, but I can't grab it. Oh, yeah. So, and yeah, we got it. So we can actually now, I don't know, like put here to JSON, and we are done. So we can now like push it forward. So the idea behind this Kotlin compiler plugin is quite tricky, and it like currently works only in K2 because of the new compiler architecture, and K2 IDE because it's also rewritten from scratch. How it works? Easy. Like we have a code that wants to add like a new column which is called new call. And instead of this, we generate this column and some scope and push this scope directly to the code. Like, and Kotlin compiler can do it. I will not stop on it, but because like it seems like if you're interested, you can read it in this issue. And probably the last thing is to sum up what we had today. So first, we had like experience with some kind of type providers using notebooks which are integrated inside. Secondly, we tried to use dataframe to analyze the like data, to transform it and visualize it with Candy. And the last thing, we actually tried this on-the-fly type generation using compiler plugin. Important notice here, this compiler plugin is totally experimental. It didn't work literally yesterday. So, but today it works. And as I promised, this is the code, more or less, that we got. And actually, that's the way how you should do it, like currently in Kotlin. And it's actually even without like reading, transforming, and writing it to JSON. So the last thing, everyone can eventually or accidentally become a product manager. We are hiring a person who is really interested to play with this kind of stuff and like finding a new applications for the technologies I showed today, Candy, notebooks, Dataframe, and also Kotlin WebAssembly. And thank you.